All right, I'll start. Good afternoon, everyone. My name is Jalal Zia. If you cannot hear me in the back, just let me know. I'll speak louder. I'm here to talk to you about ACWA Power's journey in remote monitoring and diagnostics. More importantly, I'm here to introduce the company in general because ACWA Power is relatively unknown outside of its home geography, right? Just by way of introduction, my name is Jalal Zia. I lead the remote monitoring and diagnostics function within ACWA Power, but we don't call it RM&D because that would be too boring, right? We wanted to call it something that nobody else knows, and we decided to call it Monitoring and Prognostics, or Monitoring and Prognostics Center, MPC for short. RM&D is my second love and passion. It cannot be my first love because that position is occupied by my wife right now. Just introducing the company, here we go. We're about 70 gigawatts of installed base capacity. Half of it is renewables, roughly half of it is renewables. If I'm blocking the screen, I'll just move a little bit further back. We're also a water company, so we produce about 8 million gallons per day of desal water. 4,000 employees, growing really fast. Next slide shows where we're going. We choose to define ourselves by where we're going in the next 5 years rather than where we are today because it's going to be a very different company by 2030. So we're going to grow our renewables capacity to about somewhere between 150 and 185 gigawatts, which is a fourfold increase from where we are today. And so essentially, ACWA Power is going to transform into a largely a renewables-driven company, most of it being wind and solar PV. Our water capacity is going to double in the next 5 years. And we also currently hold the title of having the world's largest green hydrogen project, together with Air Products in northwestern of Saudi Arabia. It's called the NEOM Green Hydrogen Project. We produce about 1.2 million tons per year of green ammonia there. Ammonia being the vehicle for transporting hydrogen. As you know, hydrogen is not an easy gas to make portable, right? So ammonia is our vehicle, and the advantage of ammonia is it has additional ancillary markets. It's not just power gen that you can use ammonia for. Our fossil fuel fleet, which we euphemistically call flexible generation, is going to go through this transition that happened in Europe about 10 or 12 years ago, maybe even 15 years ago, where a lot of the base load generators that were based off of natural gas or fossil fuels transferred into a flexible generation mode, right? So there was a lot more emphasis on part load, on fast start, ramp up, ramp down. This is going to happen, this is going to play out in the Middle East in the next 5 years, at least with the ACWA Power fleet. So the flexible generation fleet is not going to grow that much, relatively speaking, but there is still a 5 gigawatt increase in capacity from where 10 gigawatt increase from where we are today. But the main story is the renewables. And all of that growth is happening outside of Western Europe and outside of North America, at least from what we know today and project today. Why did we do remote monitoring and diagnostics? Just one core purpose is to help approach our contractual dispatch and availability targets. Dispatch meaning how many megawatt hours you can send to the grid, which is directly linked to revenue, and availability, which is directly linked to the reliability or how dependable is that dispatch when the grid calls upon your plant to dispatch. The way we do that is by leveraging GE's APM product line, two specific components. One is Smart Signal, and the other is known as PI today, Performance Intelligence. But when we adopted it, it was called OPM. So it's the performance side as well as the reliability side. We have intercepted and hope to continue to intercept a lot of incipient failures with the APM functionality, and we have improved heat rate, efficiency, and fuel burn in a lot of our fossil fuel power plants using the PI functionality. And I'll show you specific examples of that in the following slides. Move forward. This is our journey in a single page snapshot. So we started with the MPC Center, the R&D functionality in 2017, largely with the help of GE. Actually, almost exclusively with the help of GE. And Rahul was there at that time. He remembers it better than I do because I wasn't there. There were 2 parallel centers set up, one in Jeddah in Saudi Arabia, the other one in Dubai in the United Arab Emirates. The one in Jeddah was set up largely to hedge against data residency requirements within Saudi Arabia, which we later on found a way around. But at any point in time, that bypass path could be closed for us, in which case we would have the ability to monitor Saudi plants within Saudi Arabia, not allowing the data to leave the country. But for now, our relationship with GE is strong enough that the data actually goes to Atlanta, then comes back to Saudi Arabia or Dubai. Again, credit due to GE. In 2020, we started internalizing a lot of the subject matter expertise that was required to do the monitoring ourselves. Right? Previously, we were reliant on GE IMS services or a handshake between our subject matter experts, who weren't really experts at that time. But by 2020, they were to the point where we started loosening the strings on the IMS service and allowed our own people to start monitoring our own assets themselves. Still largely dependent on IMS by the 2020 timeframe. In 2022, we birthed our own ACWA Power Cloud, and that brought in a lot of company policy which required us to internalize all of the data, right? So at that time, and continuing to today, we still allowed GE to send the data to Atlanta and bring it back here, and that's going to continue just due to the strength of the relationship we have with GE. Otherwise, any new plants outside of the legacy GE executions that we did on our plants are subject to this requirement that the data must go to the ACWA Power Cloud, where all the analytics, the processing takes place, and then come back to our monitoring centers. In 2024, that's when we started this Vision 2030 program, and you saw the projections from that were exponential growth in the renewables, doubling the water capacity. But we realized, or at least I realized, that the exponential growth of solar and wind is going to constrain my R&D capability because A, we didn't have a platform for APM, or at least a smart signal-like capability for wind. What we had was very rudimentary. It was a pattern recognition software from a third-party provider. I'll show you some examples of that. But in 2025, we again went back to Rahul and we said, give us smart signal because we want to use it for our own platform to deploy on wind and solar sites. So this is, I think it's a first of a kind, right? Where we are taking smart signal, integrating it into our own platform, together with the performance monitoring functionality, which we are going to build ourselves. But because we scoured the market, high and low, we could not find a product that was as capable and as experienced in the market as Smart Signal. And we said, well, this is it. If we're going to go with an APM Smart Signal-like functionality, it has to be Smart Signal, right? That's a conclusion we came to independently And we looked at multiple vendors. It wasn't just GE, and it wasn't just because we were good friends with GE. Hence the drive towards this integration with our own platform. Okay, so the capabilities that we have been able to develop through evolution. By the way, if you see me wince a little bit, today was leg day at the gym, and I hate leg day. I'm cramped. The first one is real-time monitoring. It goes without saying that all the data that we're analyzing is real-time, except when we have data interruptions. And in those situations, we actually require the plant to send us CSV files manually, which then removes it from that real-time category, right? And we do have a lot of data interruptions. It's something that I have a dedicated slide to whine and cry about. And to those within GE who I've spoken to one-on-one, I always make it a point to complain about the lack of robustness of the data pipeline. And it's not just your fault, it's partly our fault also. And we don't have a solution as of today. Unintended outcomes. What has played out, at least within our fleet, is now the APM functionality that we developed as a handshake agreement with GE is largely being seen as a risk mitigation within ACWA Power. How? Number one, we've been able to develop this credibility that, hey, you can catch incipient failures. There's plenty of examples within ACWA Power where we've been able to catch incipient failures and produce direct value for the plant, for the project company. The other credibility that we've developed is largely because of this performance intelligence capability, is we're able to help the plant improve their bottom line by reducing fuel burn for the same amount of power, by improving their heat rate. I'll give you another example, which is totally unexpected and unintended, at least when the APM product was being envisioned, is that now plants are asking us, well, how do we improve our heat rate? Can you give us scenario studies of, changing the inlet filter or changing the evaporative cooler or maybe reducing the vacuum on the condenser during certain parts of the season? So it's both hardware and operational SOP changes that we are being asked to investigate. And this is, heading off in a completely different direction that wasn't envisioned at all. And it's only happened in the last 2-3 years. I guess I've spoken about all of these functionalities. I'm going to move on. Okay, so along the way, there have been numerous challenges, but I'm only listing my top 3 here. The first one is during deployment of an APM-like functionality, whether it's smart signal or performance intelligence or both. On an average combined cycle power plant, there's about 1,400 tags that all need to be linked to instruments on that plant. Those instruments then need to be put on a calibration cycle, right? I will laugh under my breath when I say that, because ACWA Power does not have the operational discipline to be able to put 1,400 instruments on a combined cycle plant, on a calibration cycle, and then follow that discipline. We just don't operate that way. So it's a big cultural transition for us, or has been and continues to be. I don't have a solution to this challenge as of today. The other thing that this does is it strains the expectations of our stakeholders. So the project companies, the project sponsors say 1,400 tags, that's going to take you 2 weeks, right? No, sometimes it takes months, and on occasion it has taken us years to complete implementation on certain combined cycle sites. So managing expectations on a combined cycle site or a complex site has been a challenge, continues to be. I've talked a little bit about data connectivity. The plot below shows the data quality from, for a period of 1 year from a plant in South Africa. You can see that we've only had data uptime for about 40% of the year. This was a 12-month period, let's see, ending in March of 2025. So data uptime is a huge challenge. And this is not the worst plant in my fleet as of today, right? Whenever we are operating blind at MPC, it's a huge challenge for us to maintain stakeholder engagement. And I need to find a systemic solution for this problem. I don't have one today. The third one is centralizing subject matter expertise. What that means is we have over time, largely with a lot of help from IMS, from the subject matter experts within the GE umbrella, developed our own capability to diagnose and then fix incipient problems and also now performance problems. That's both a blessing and a curse, because now you have developed this reputation, this credibility that you can solve problems at plants sitting, thousands of miles away in our R&D center, and now plants are expecting us or pointing at us, asking for resolutions to their problems because their own performance engineers or their own O&M engineers cannot solve those problems. Okay, but along with these challenges, you weigh them against the opportunities that we've been able to avail as a result of this EPM deployment. Just in the last 1 year, 12-month period alone, or in 2024, we've been able to save about 445 gigawatt hours of electricity that could have not made it to the grid because we intercepted incipient failures because of the APM platform. That's huge, just that metric on its own. In addition, due to the PI functionality, we've been able to improve our bottom line, reduce fuel burn by about $6 million in just those 5 plants in 2024. Again, for the company, for my function, part of that goes to my bonus, right? I hope, big percentage. The third functionality is an unintended one again. Maybe it was intended, but because we have now centralized subject matter expertise, we're able to take learning from one plant and apply it to another, right? I'll give you one example. So at IBRI Combined Cycle, which is in Oman, one of the plants in Oman, during one of the inspections on the HRSG, it was noticed that the baffles in the attic and the basement of the HRSG are missing. They're just not there. This was about 8 or 9 years after the plant had been commissioned and fully operational for those 8 or 9 years. Then when we reversed back into the data, we realized that HRSG effectiveness had been below par, below HMB, below its heat and mass balance for the last 8 or 9 years, and nobody had noticed, right? And we said, well, why don't we just do a quick CFD study and evaluate whether there would be a benefit to putting those baffles back in? And lo and behold, the CFD said, yeah, you'd gain 2% effectiveness on the HRSG, about 6 megawatts on the steam turbine if you put those baffles in. And so we did. We put those baffles in. We designed our own baffles, put them in. We didn't tell the OEM. And we got 2.5 megawatts from the steam turbine. It was less than the 5 that the CFD result showed us, but 2.5 megawatts for essentially spending just sheet metal money on the HRSG. And those scenario studies were carried out in Epsilon. I was going to say gate cycle, but it was done in Epsilon, right? Largely because of the subject matter expertise that GE helped us develop. And then a few months later at the Sohar power plant, we noticed, well, this HRSG, also doesn't have the baffles, and is also from the same OEM, right? So there's this OEM out there, HRSG OEM out there, that's going around the world installing HRSGs that have no baffles in them. Forewarned. Check your HRSGs. Do they have baffles or not? But then, using this capability of, hey, we did this at plant A, why don't we try this here? Because it's the same HRSG, same model number, same OEM. And lo and behold, we did that. And from both of those plants combined, we are now saving about $200,000 a month in fuel. Again, huge. Thank you to GE for helping us develop the capability. It's a question of, you give a man to fish, which is the IMS service. You teach a man to fish, which is the hand-holding that GE did with us and taught us how to do this, right? The other thing that has really helped is poaching GE employees, right? In fact, I think that has helped us more. Good strategy. Okay. I think those numbers were supposed to be in a straight line, but it's okay. This graph, though anonymized across multiple sites, represents 5 sites where we have accurately recorded the values generated from both the PI functionality and the smart signal functionality against the costs paid by the plant to enable those functionalities, right? So in the first column, you can see the total value generated from PI as well as smart signal is close to $14.5 million for, this is accumulated through the life of the plant, right? So this is perhaps an older plant, which has had 8 or 9 or 10 years of operation, maybe 7 of those with the APM function. And we've been able to gain about $14.5 million of value from the APM rollout at this particular plant. And through those years, that plant has paid about $810,000 in fees. So that's a multiple of 16x, right? 1/6. Again, that's huge for the plant. It helps me retain my job, right? The second plant, which is perhaps a newer one, the multiple is 12x, right? Power and water plants and CSP plants are the newer ones in our fleet. So the multiple isn't quite that much, but you can see it's still very, very healthy in terms of how many orders of magnitude, how many multiples of the fees we've been able to generate in value generation. Okay, so I'm going to go through 3 very specific success stories. One particular success story I'll talk about here, and then I'll skip over the other 2, is an APM success story, APM smart signal. So bearing number 5 on steam turbine number 3 in one of our combined cycle plants, not mentioned here for privacy, we saw an increase, we saw an alert on APM, right? And APM told us, well, the vibrations on one of the bearings is increasing, but at the same time, why is the alert generated? Because it's not just the vibration signature, but also the metal temperature is increasing, right? This is the capability that only Smart Signal has, and a normal DCS operator would never be able to pick that up, right? No matter how astute they were and how attentive they were, a human cannot watch 2 different signals and correlate them in a 24/7 mode of operation. We intercepted that. We informed the plant. The plant took an opportunity to do a borescope inspection and realized some of the oil injection nozzles in that bearing were broken, and there was some limited damage to the bearing pads. And that was the beginning of a dramatic failure, but we intercepted it, right? And that catch alone represented about $400,000 in savings. a similar situation, but this time on PI, where we picked up a deficiency in evaporative cooler where a plant was not able to meet its capacity test. It's called an NDC in the Middle East. That catch from the PI platform helped us recover about $350,000 in value. The final one here is not a GE story. On our wind site, on our only wind site for now, wind is growing fast, but we only have one site online for now. We did not use GE's APM platform, largely because at the time that site was commissioned, GE did not have a wind power platform. We used a third party, which had a very rudimentary APR functionality, which is pattern recognition. But using even that rudimentary functionality, we realized that bearings on that site on the wind turbines were being replaced far too frequently, right? If you did a historical backcheck and you looked at failure signals on that particular site, you could maybe reduce that frequency of bearing replacements by half, which we did. And our bearing failures did not go up, right? Again, that saved us about $81,000. This is what excites us about now being able to integrate a complete end-to-end APM smart signal functionality on our wind platform also. Okay, lessons learned. The first one, again, about data pipeline, right? What was unintended and completely unexpected when we started deployment is how tenuous our data pipeline was going to be. And it's become a huge issue for us. You can see the value numbers that we presented in the previous slides, right? How much value we're generating with very limited data availability on certain sites, right? If we could increase that to 100% data availability, make that data pipeline more robust, how much more dollars can we generate? I mean, it's an easy calculation. This is, again, an unintended outcome. Is the way ACWA power plants is structured is we have three parties within a power plant. There's the MPC function, which oversees all the data from the power plants and runs the analytics. There's the site O&M team. And then there's the power plant ownership, which is a project company. Some of it may be ACWA Power, but the project company is an independent entity. The project company pays for me. It also pays for the O&M service. So there's a natural tension, right? The project company could come to me at any time. Hey, I paid you, we are P&L, I paid you X thousand dollars for your service last year. How much money did you save me? I can give them a number, but that number is not what the O&M team is going to give them, right? So there's a communications tension within a power plant with how ACWA Power's fleet is structured. And the way to overcome that natural tension is to bring people on board. So we've made champions within power plants, within the O&M team, who are now running the APM tool. We're also doing a communications project within the project companies, which are independent entities, to help them understand the value that MPC brings. And that wasn't always understood. It still isn't. So it's a work in progress. Just a little window into what we perceive as the future of at least the power plants within our fleet. One of my main challenges is as the fleet grows, we're doubling up, we're 4x on our renewables capacity in the next 5 years. I cannot hire 4x the number of people to staff the APM Smart Signal and the APM PI. I cannot hire that many subject matter experts. A, they don't exist in the market. B, they're very, very expensive. So how do I grow my capability to monitor these plants and keep providing a value chain to these plants? Well, one of the thoughts that I have been seriously pursuing is, can we digitize, can we get a machine to take over, let's just say 80% of the function of these subject matter experts and only leave the 20% really high value, really difficult cases for the humans to tackle and resolve, whereas a machine resolves the others. It does the analysis, runs the analytics, whether it's AI or, as Rahul likes to call it, a RAG or an LLM. I'm agnostic to the end solution, but I'm looking for the solution because I need it, right? This is the future of how ACWA Power is going to be running in the next 5 years. My management is talking to me about completely autonomous power plants, at least in the wind and power domain, right? Not combined cycle. How do I get there? I need to at least start with this functionality. So this is the vector of the future of power plants. I don't see it for gas turbines yet, but at least for wind and solar, this is where we're going to head. All right, thank you.